Pleasure to be with you this afternoon. So great to meet you. As mentioned, I have a background of physical engineering. I had the chance to spend years at the EPFL, and I had the pleasure in the mid-90s to work on solar cells with Michael Gretzel, field emission of nanotubes with André Chatelain, and as well spintronics. So over the last 10 years, what I've been doing is looking at technology, nanotechnology only, companies, building companies, and investing in nanotechnology. So what I'm going to be doing this afternoon with you is simply share what I have learned over the last 10 years and share with you what we do with Nanodimension, and based on that, try to get some global trend. So as mentioned, we have activities. We started in Switzerland, and we're still with an office in Zurich, and we have opened 3 years ago activities in Menlo Park, California. So about the story, started with an idea in 2002, and that was the collapse of the internet bubble, as well as the venture capital model. So it took us some years and perseverance to convince investors to trust that this passion about nanotechnology will make money, because at the end of the day, this is what we're targeting. We've been able to close our fund in 2005 and develop this capital with the first investment in 2006 in a company out of Grenoble. And actually, there is some technology coming out of the EPFL into that company. And I'm going to release an important news that we had 2 days ago with Crocus. Then we've been deploying this capital as well on the East Coast and West Coast of California. And 2010 has been for us a major year in terms of attracting some of the most talented CEOs into the portfolio companies. 2011 is the years of the deals, and we had, a few days ago, an important deal. It has been quickly asked, what about return? And one thing which is interesting is even starting with an idea in Switzerland to invest venture capital model out of Switzerland. Today, we are one of the top performer venture funds in the US compared to the peers. So it is possible to make return with that field of investments. What and where are we investing? Traditionally, there is two domains of investment: semiconductors, electronics, and life sciences, because there is a strong demand for innovation and a strong demand for integration. So by definition, those two fields are venture type of investments, because they are domain and industry where we cannot wait 20 or 30 years to be basically able to transfer that technology into those industry. Energy domain, you saw the last 5, 6, 7 years, massive amount of investments in solar cells, in battery, and we know now where the race has been won with Asia. I think that there is as well some additional developments that we can look at, including the grid. I was speaking with the CTO of the largest holding owning the grid, and only if they had to replace their high voltage cables, they don't have, and today there is not enough copper and aluminum in the world just to supply the demand of cables. So coatings, in order to extend corrosion and lifetime of those cables, anti-icing, because global warming means as well some change of a climate where you have power lines collapsing because of ice, where usually they were designed to never have icing. So here as well, I think that especially after 2 decades of consolidation, you do have even conservative industry which start to be open for innovation. The type of investment that we do is from a few €100,000 or Swiss francs or dollars to several millions. And I think this is really what reflects today the domain of nanotechnology. There is a strong need to help and support entrepreneurs out of the lab with ideas in order to demonstrate, get to proof of principle, first prototype, but after, it's massive amount of capital which is required in order to go to profitability. And of course, it's going to depend to which sector you are active in. Where do we invest is what just the best technology is. And I think instead of just covering geographical focus, I think we should think about localization. Because localization becomes so central in our activities in nanotech. Where is my IP coming from? Where is my IP going to be located? Does it have to remain in Switzerland, or do I go somewhere? You saw Google taking all its IP out of the US and putting it between Ireland and Netherlands just for tax savings. Then you have, where am I going to get my CEO? Who is going to be my CEO? Where where am I going to get my VP engineering, my VP manufacturing? Where do I get the talents? And most important is, where are my customers? If my customers is in Asia, does it make sense to keep my company in Switzerland? Especially when I'm going to have to get a local team of people. If I believe that I'm going to be able to sell something to Samsung by just coming nicely and believing that after a glass of sake I'm going to be able to get a deal, it will not work. I'm going to have to get local people who go to school with those people, who know them, who live in the same village in order to get a deal. So here's the thing, is how and where are we going to be active with our nanotechnology startups? And the investment style is we structure those companies. We negotiate the term with the founders, we raise the money, we build up those companies. Today, our activity, Switzerland, California, and our team of 8-9 people is one thing, but before and more important is all the network that we access, the experts. We work a lot with some of the Swiss labs to do testing and to test the samples of those companies that we look to potentially make investments. And of course, you have a community of experts that we need in order to understand how complicated it's going to be to scale up the technology and or how difficult it's going to be to integrate it and to transfer it to industry. One element of our team, if you compare, is the amount of PhD and background, we always engineering background versus the traditional venture fund, which is focused on MBA. So when I built up Nano Dimension, it was evident that we have to understand the science, we have to understand the engineering to do the scale up, because this is more critical than the science. And after, it's going to be building up a team that is strongly focused on execution. And this is basically the type of skill that we wanted to get first within our company before being able to work with people. Those figures is just to give you a sense of what is the size of the industry today. Since we started in 2002 to today, we have reviewed thousands of companies. Last year only, we received about 1,700 business plans. This is the size of what we're talking about. And this is just our group. This is just Nano Dimension. So imagine what the other venture funds are seeing as well. And from those 1,700 last year, we had only one investment. Now, another figure that I wanted to share with you is the trends up. If I take the figures of 2007 and I take the figure of 2010, the company that we have visited, met with management, look at in detail, that represented 173 companies in 2010, were about 55 in 2007. So you double in less than 4 years. So one of the very strong trends that we see in this industry is you have more high-quality deals in that industry. So this is one of the fundamental reasons why I can really stand that. Does it make sense to invest in nanotechnology? Yes, because number one is you have deals, and a lot of deals. What is an interesting trend is as well is, I remember the Swiss Nanotech Roadshow, 2002, 2003. We went to the US to meet with the peers, and we were hearing about big amount of money being deployed to build up nanotech centers. And Switzerland was already with prototypes, you know, wonderful millipedes that we are being able to show, and other applications. What the trend is, as you can see, the deals that we see is you have a massive trend in commercialization that even if Europe had, at a point of time, some leadership in innovation, and we saw the number of patents in 2005, that we are highest number of habitants, I think in terms of commercialization, the trend is not there. And I think this is where we really have to roll up our sleeve and to support the entrepreneurs that are basically building up the innovation for the future of our country. In terms of trends within the sectors, so about 50% in life science, we definitely saw some increase in energy. But what is, and this is about the nature of what we do, is we focus very much on the early stage, so we're still early stage company. So the major trends is what we're seeing based on our data is more and more high quality deals and flourishing entrepreneurship from North America, but as well from Asia. So what are we looking at? If I take a bit a sense of, you know, those first companies that were appearing 2003, 2004, that was making some noise, those were large technology platforms, but there was not much application. What we have today is large technology platform, extremely focused, in order to validate this platform within 1 or 2 products. And that means as well a full different staffing of the company. It's not anymore material science that's just going to try to go broad and see and show as much they can do. Now, those are experts of industry joining those companies, using those platforms to clearly focus on one application and demonstrating that application. And I think the concept of tunable platform is fundamental when you build a company. You need that. You need to get the flexibility because down the road, you never know where you're going to end up. And a one-trick pony company is a dangerous choice because the company evolves over the time, and your technology has to be able to evolve over the time. So technology platform and the real breakthrough is fundamental. The cheaper and better is not enough. I think that when you build a company, the only thing that we cannot be short of is ambition. So breakthrough is absolutely fundamental. The item as well that we see, and if I look at the evolution of the company, we had at the beginning, 1 or 2 patents by company. The portfolio company that we have, we speak about hundreds of patents per companies. So it is important, and especially that when you open a new field, that you're not cheap, but you still remain very focused on what am I going to protect. Because this is going to be not only to defend yourself, but as well you're going to have some time to be offensive. So building up important portfolio company. And the team is, as mentioned, this is the key. I think that when you have, and that was one of the early disease, if we can call it like that, of the nanotechnology startup was because materials could do so much. We were continuing to build up those companies with material scientists focused on developing and manufacturing tools. This is definitely not enough. Because at the end of the day, if you're just a carbon nanotube manufacturer, who try to sell it, today you can buy for 50 cents a kilogram of nanotube of China, and they produce tons of nanotube for the battery industry in paste that they integrate in carbon, in anode and cathodes. So basically, you will not go very far on it. Now, if you say, I produce carbon nanotubes in order to build up cathodes for battery, and I sell cathode or I sell battery, it's not the same staffing, it's not the same CEO, it's not the same VP manufacturing. Those are people specialists in battery, in addition to the expert in material science. But from day one, it means that you're going to staff your company, you're going to build your IP in a completely different way. And this is as well on the IP side. What we've been seeing is most of the time, people were focusing on how I'm basically going to manufacture my nanoparticles or my nanostructures, and they were spending all the money on basically a manufacturing tool that they were protecting. They were not thinking about the formulation, patented the formulation, not about the application. And the most value, if you can get, is on the formulation, and of course after to protect the application. So I think this is really something that this industry has learned, and now basically the company are application focused. So we have been establishing a portfolio of company within the life science, within the IT electronics, within the materials, and we've been lucky to already had exit company that we've been able to merge and put on the NASDAQ, and that was in less than 20 months investment. And by the Selecta in the life science, I'm going to come to them, in the drug delivery, in new type of synthetic vaccine. SBA is a low-K dielectric for next generation of 32, 28, and 16 nanometer size semiconductors. Soludyne is electrochromic windows, application in energy saving. And Crocus is an MRAM company. So if we look a bit more in details of what does it took over the last 4 or 5 years, and what has been our journey with those guys. So it is a company out of the CNRS SpinTech in Grenoble. Some of the fundamental IP come from the EPFL. And what we do is we do thermally assisting switching, so MGO or various type of thermal barrier, and we have 2 layers that we're going to be able to change the magnetic domain. With that, we do non-volatile SRAM, if you want, 12 nanoseconds for writing and 12 nanoseconds for reading. And today we have partners with Tower Semiconductors, where we're manufacturing our chip, and those chips should enter into the market by the end of the year. Already about 60, 70 million Swiss francs as investment went into that deal. And the big news is 2 days ago, we signed a $300 million investment into that company. So what you see is those ideas within 4 years can attract massive amounts of capital, and we're going to build up the first magnetic foundry in the world to manufacture magnetic random access memory. And I'm happy to, and I hope there are going to be questions about that, because I spent 8 trips to Moscow to close that deal. Bind Bioscience, this is nanoparticle for drug delivery. And it's a new class of pharmaceutical, 100% synthetic. This first company, the first program is in the clinic. So we have started injecting humans. So what you have is, within nanoparticle, we are, in this case, able to encapsulate docetaxel for breast and prostate cancer. It is the nanoparticle make the drug completely stealth, and with the targeted ligand, we penetrate within the cancer cells. So 2 mechanisms. One is the EPR effect, which is basically the cancer cell damage the blood tissue, and because of the size, it's just fluidic. The nanoparticle fall into it. The targeted ligands stick on the cancer cells, and basically the cancer cell eat up the nanoparticle. Because the pH is higher, it dissolves the polymer. Today, in animal model, we have for 10 times less active compound of chemo, we have 5 times more effect. So we have a ratio of 50. So if we're able to reproduce that in human, the target is very limited side effect to chemotherapy treatment. Now you see tunable platform. We have done hundreds of thousands of variation of the nanoparticle about the size, about the pH, about the hydrophilic, superhydrophobic, the type of ligand. And now that we know all those parameters, we can just replace the targeted load, the therapeutic load, or the ligands, and we can do cardiovascular disease, inflammatory disease, and pain. Now, this platform that can cover the world, the company and the equity money is focused about one clinical program, which we have now in the oncology field, and after with partner, we extend the various application. But it is important that those tunable platforms, they get validated, otherwise you don't create value. The technology come out of MIT Robert Langer Lab, and as well of Omid Farazad from the Brigham, so Harvard. And in this company as well, we speak about close to $50 million that they invested so far to bring the company here. We spoke about toxicology and risk. In that company, we have on the board the gentleman who wrote the FDA rules. So the general counsel of the FDA is on the board. Bob Langer is the chairman of the scientific advisory board of the FDA. So there is already a lot of regulation in order to go down the path with the nanoparticles. So I think that it's important to discuss about those risks. It's important to follow and to have the rules to evolve. But it is extremely important to let commercialization and to let those companies evolve in Switzerland as well, because they're going to go very fast outside Switzerland. Selecta is a fully synthetic vaccine. And what we have is this kind of same construction, but in that case, you put T-cell antigen as well as adjuvant. So basically, a very small amount being injected. It goes to the lymph node and basically ring your immune system and say, hey, wake up, you're under attack. And this is basically what we do to give you the sense of how quickly it can go now. After having been able to develop the platform and the platform work, on Monday, there was a team meeting, a staff meeting, and say, hey, let's try to do H1N1. By Friday, the vaccine was manufactured and injected into animal to start the test. 4 days. I mean, this is unprecedented into the history of designing a vaccine, of being able, in 4 days, synthetic fully manufacture a vaccine. Last company I'm going to mention is ion migration within metallic layers. And here we do windows. So basically, you have a controller, and depending on the voltage that you put on the windows, you go from fully transparent to fully dark windows and any intermediate step that you want. You don't lose the transparency, but it's like putting a variable sunglass onto your windows. The attractivity of that system is, and today with Soludyne, we are manufacturing windows. And we have 2 test rooms, the sun room that you have winter garden or covered with Velux and product systems. We basically have those 2 rooms, one equipped with low E double pane glass, and the other one with the active windows. And if we say to the AC, keep the temperature to 15 degree, 20 degree, 25 degree, we can save between 40 to 70% of the energy consumption of the room. In addition to that, you don't have the problem of having all the glare and the fact that sometimes you need curtain and additional infrastructure to be able to remain into the room. So, interesting development. Now, what I wanted to bring is, if you think, when we were back in 2002, and for quite a period of time, I was knocking at door for investors, telling, listen, nanotechnology is coming. It's going to be not only a passion of science that's going to help to contribute to advancements in innovation in technology. In addition to that, we're going to make returns and we're going to make money. So a couple of years later, and that was the same talk I gave at the 10 years anniversary of the NNI in Washington, where they spent $16 billion of dollars for that, is government programs spending so much money. Do we deserve the trust of the taxpayers for the money that has been used into those domains? And I feel very comfortable, not only because there is more deal, but because those guys are joining our startups. Bertrand Cambou was the CTO of Motorola. He was as well the CEO of GenPlus. He was one of the 4 officers of AMD. He was the CEO of the joint venture between Fujitsu and AMD, multi-billion-dollar company that do all the flash memory that you have today. And he was as well the CEO and the president of SST, which is today all the technology being developed for the flash memory. Bertrand joined Crocus, a little startup out of Grenoble, which has as well operation in California. Why? The attractivity of the stock. Because how you make money is by being a shareholder of a company. If we take Bind, excuse me, I go back. If we take Bind, Scott Minnick did already 4 companies public. And Scott brought the first liposome company into the market and built like a blockbuster as well. And how it worked and how did we get Scott into that company? Scott was a partner of Arch Venture, which is a solid investment company in California. And we call Scott and say, hey, we are investing in Bob's company. We're moving ahead. Do you want to join? He put some money into it, and he fell in love with the company. And he fell in love so much of the company that he quit his position as an investor and became the full-time CEO. Here as well, the reason is because you can build up amazing company. If we look at Selecta, Werner Kaltrils was the SVP of Sanofi. He was the CEO of Solvay Pharma that he sold for close to $7 billion to Abbott. And now he joined a nanotech startup in Cambridge of 15 people. Why are they doing that? As well, attractivity of the stock. Their salary is being divided by a factor of 4 or 5. So I think that, and then last but not least, Rao was the GM of Novellus, and is now the CEO of Solodyne. So you see, I think that what we've been seeing in terms of evolution of nanotech, 2010 has been for us the year that has attracted some of the best CEOs in the world to join nanotech startup. And this is a massive milestone, I think, for our portfolio, and I think as well for the industry. And if we look at what we do, you bring leadership into a 160 billion market size, and potentially the flash is not going very well. The solid-state drive neither. So there is a need, and the FARAM never worked. So basically, there is a need now for what is the next generation of technology. And if this one works out, I mean, it's a huge success. So you bring new leadership to industry. You solve potentially side effect of chemo, or you bring new type of vaccine, or you save energy. So the nice thing about what we do is not only to target to make money, but it's as well to definitely bring leadership to industry and do good to society. And this is the fab of Solodyne now. You see, this is the thing. We're deploying $100 million with $70 million coming out of debt with 0% interest to build up that. And we're going to be manufacturing windows of 1.8 meter times 1.2. This is creating 350 jobs, manufacturing, blue-collar, technical jobs. And if you think about the future of Western countries, innovation is key to keep ahead. But at the end of the day, we need to create jobs because otherwise, there is not everybody who's going to be a PhD and doing some nice research. We're going to have to get the people to basically manufacture. And creating blue-collar job is, I think, one of the biggest challenge of our Western society. Services company is going to have enormous trouble because today it's worldwide. Service companies are based in China, are based in India, and it's more and more difficult for even our banks to compete globally. So it's going to be through innovation, but not only through innovation in research, it's going to be through innovation to do manufacturing job. And I think nanotechnology can do that. So it has been asked to me, but okay, it's nice, good science, good CEO, you bring to do some good to society, but at the end of the day, can you make some money? If I take our, what is called total value to paid in, and we compare to the top US quartile venture fund of the industry, or to the European, the small fund out of Switzerland focused on nanotech is outperforming. So it means that even on an asset class, you can make money. And Ixellus, the investment that we did in May 2008, just before the collapse of the stock exchange, we invested in May 2008. We merged the company in December 2009, and we do a solid 2.5 times our money. Of course, if the stock exchange would have been better, we would have done even more. But when all the portfolio were losing 60, 80, or 100% of the value, we were able to do 200 times, 200%, I mean, two times money. So, to conclude that talk, is the message that I have for you today is it making any sense to spend money in nanotechnology? And I feel very comfortable to say yes, because we have more deals. We have the guys to manage those companies. We bring value to society. We can create manufacturing job, and we can generate return. I thank you very much for your attention, and I look very much forward to your question. Yes.
Thank you very much for your nice presentation and bring excitement to the nano community that you can really get nice startups. Questions? Hans?
You talked about platform, and this all makes sense. But then you show MRAMs, and MRAMs have been discussed a while ago. And today, I think MRAMs may come back, but with spin-torque switching, yet what you show on your slide is switching by classical fields, which isn't necessarily scalable to smaller dimensions. So I wonder whether this is just on your slide, or whether it's really they found a solution to make things more reproducible and scalable to smaller scales.
Yeah. So to answer your questions, we have one field line, not two, one. Because of the task, we can basically, we keep the heat within the tunnel junction that allow us to be above the Fermi temperature, which is a very easy switch. And what we've been able to do, the dot size is one element, but the scale down of the MRAM is absolutely not the magnetic dot. It is all the CMOS. So we can use 65 nanometers CMOS and put our 130 or 110 or 90 nanometer size dot, and it's worked wonderfully well. The spin torque is scalability, is even demonstration to manufacturing side. And I think this is where basically spin injection is very challenging. The fundamental IP of EPFL are basically those fundamental patents about polarized current within a magnetic nano domain. So far, when it is to manufacture, we do with one field, it works very well. And the platform of MRAM can be expanded to many additional products outside the memory field. And we have plenty of applications that are now, including on the security side, in development.
Well, perhaps in the same vein, could you talk a little bit more about the prospective customers for that technology?
So if we take on the MRAM, the first application, the battery-backed SRAM, so you replace basically it's pin-to-pin compatible with the Cypress or Maxim SRAM, which use a battery. So when you have power failure in optical network, what you have to do is you need to download the data very quickly, and only the SRAM is able to do that. The problem with the SRAM is electric, and you lose information if you don't have the electricity. This is what you have in your computer today. To be able to be magnetic, then basically you don't lose information. So you can remove the battery out of your system, and that basically it's a gain of maintenance, on cost, and everything. This is the first generation of product. After, there's plenty of application.
Are there any additions?
Can you explain a little bit more on the electrochromic windows?
Oh, yes. So, and this is the beauty as well of, in this case, Silicon Valley. It is sputtering of various layers of metal layers. And what we've been able to do is to acquire for $1, $100 million line of Seagate that was basically shutting down. And we've been able to use that line in order to basically build up over 2 years all the parameters that we needed on large glass windows. So this is something that if we take, it would have been very difficult to do in Switzerland, because we got for a very small amount of money an amazing equipment in order to basically optimize all the layers that we need. Now that it has been learned, and that especially to get a non is easy because it's ion migration, but to get intermediate level is not easy. And that was basically this tool, and the flexibility of this hard drive disk line gave us the flexibility to learn about that in order to develop the technology. And now we are building the fab that I just showed you with very large sputtering equipment. So it is 100% metallic layers.
We have still time for additional questions. Let me ask you, what is your advice for Switzerland to change the situation for nanotechnology startups?
I think it's to glorify entrepreneurs. It's to glorify and help them. It's really, I think, what we need to do. And I think that there are institutes and initiatives to help them. I think that we need to boost them. And the way of boosting them is as well to take them outside Switzerland. I think that, and this is what I try to do, is we invite entrepreneurs to come and spend the summer weeks with us in California in order for them to test the market. So don't wait until you have your prototype or you have already got your first round of funding or second round of funding before going and speak with your customers. Go as quickly as possible. Go to Asia, go to the US, go outside, understand who they are, because that's going to basically trigger where I'm going to be spending my money on the IP, how am I going to write my patent, what type of equipment do I need? Can I get a deal like the deal of Sonodyne, where instead of just buying some sputtering equipment that's going to cost me a fortune here, can I get a deal where some, even a full manufacturing line can be purchased for a cent on the dollar? So I think is to support them, to help them, and to as well help them to go and see what is happening outside in order to be stronger inside.
Did I get this right, that the difference between Nanodimension and other venture capitalist company in the nano field is that you have more scientists as leading personnel compared to the other investors? I mean, it's very nice to hear that as a scientist, that now science plays a good role also in financing, which I always believed is the key to success. But how could you convince, I mean, at the end, the money comes from rich people. It comes from bankers mostly, right? Probably also in your field. And so how could you convince as a scientist the people after money?
The first money doesn't come from bankers. It never comes from bankers. It's going to come when you show very big return, and they're going to come for product number 3 or number 4, number 5. At the beginning, they don't take the risk. So the people that are going to help you are entrepreneurs, are families, are foundations, And this is where you need to spend your money, your time, because it's very difficult for any large institutional investors to be able to come and invest into what you do. And after, for an entrepreneur, there are organizations like us. This is the only thing we do. We only speak with entrepreneurs. We try to understand how we can basically build up that together. But we're not easy, because we're going to challenge the science first to be fully convinced.
So thank you very much
my
for
pleasure.
your talk and for the discussion.
Thank you.
This is a blessing.
Merci.